Today we're going to learn about the Pythagorean theorem and its converse. Now this is something you're going to be using for the rest of the year in geometry, and you're going to be using it in any later math class. So very, very important chapter in geometry. The Pythagorean theorem, that's what I'm going to start with first, is a squared plus b squared equals c squared. Okay? So a and b are your two legs of a right triangle. So it's the two sides that make that right angle. It does not matter whether you do the short leg or the long leg first. You just need to put those two legs, square them, add them together, and that will equal your hypotenuse squared. So that's the basic formula for the Pythagorean theorem, and I believe you've already seen this before. But since it's such an important topic, we spend a whole day learning it. Going back over here, a Pythagorean triple is a set of non-zero whole numbers. So A, B, and C need to be whole numbers and satisfy the Pythagorean theorem. So there's two things. They need to satisfy the Pythagorean theorem and be non-zero whole numbers. By the end of this class, you'll probably have some of these memorized. These are common ones. The 3, 4, 5 is very popular. 5, 12, 13, 8, 15, 17, 7, 24, 25 are a few. So if you were to take these numbers, plug in the Pythagorean theorem, they would work. That's making a Pythagorean triple. If I go back over here, the converse of the Pythagorean theorem is if you have three sides that satisfy the Pythagorean theorem, then this is a right triangle. So what they're saying here is if I took 13 and 84, squared them, simplified, I would get 85 squared. Notice that they got the same numbers at the end. So that makes this triangle a right triangle. Also notice that the two shortest sides are the legs. The longest side is the hypotenuse. That is always true because remember last semester, the largest side is always across from the largest angle. Here's some theorems that stem from the Pythagorean theorem. I'm going to go over this more when you see a visual with this, but if you have the legs being smaller than the hypotenuse, so the hypotenuse is larger, this is an obtuse triangle. If your hypotenuse is smaller than the two legs, it creates an acute triangle. So I'll go over that more tomorrow when you can see the visual of that. So for number one, we have to figure out whether the legs form the sides of a Pythagorean triple. So remember, we have to check two things. We have to first check that they are non-zero whole numbers. Okay, so if I look at 5, 12, and 13, those are all non-zero, and they're all whole numbers. So number one is yes. One of the qualifications is yes. The second part I need to check is that they satisfy the Pythagorean theorem. So what I need to do is I need to plug those numbers into the Pythagorean theorem. So the Pythagorean theorem is when I take my two legs, so 5 and 12, square them, add them together, and I need to see if they equal. I need to see if they equal the hypotenuse squared. I put a question mark over the equal sign because I'm trying to check if that works. So now I'm going to simplify. So 5 squared is 25, 12 squared 144, 13 squared 169. If I add 144 and 25 together, I get 169. And sure enough, this checks. You get 169 equals 169. So does it say satisfy the Pythagorean theorem? The answer is yes. So is this a Pythagorean triple? Yes. Okay, next one. Same thing. First, I need to decide if the sides are all non-zero whole numbers. And the answer to that is yes, they're all whole. Second part is I have to see if they satisfy the Pythagorean theorem. So I'm going to take the two legs, 6 and 10. I'm going to add them together and square them. And I have to see if that equals the hypotenuse squared. So now I'm going to simplify. So I get 36, 100, and then 400. Looks like this one's way off. Those are not equal. So this does not satisfy the Pythagorean theorem, which makes this not a Pythagorean triple. Letter C, I already know the answer. Are these non-zero whole numbers? No. Radical 13 is not a whole number. It's not a whole number. So this answer is no, right away. Now we're going to use the Pythagorean theorem to solve for certain lengths. Now there's going to be some easier problems maybe on your homework. I did the hardest ones on your notes. So if you can do these, you can do the other ones on your own a little easier. So here we have use Pythagorean theorem to find x. Leave your answer in simplest radical form. We are going to be doing simplest radical form until the end of time. So you might as well just get used to it. So for letter A, we're going to use Pythagorean theorem. So our number Pythagorean theorem, if you take your two legs, square them, add them together, and that'll equal your hypotenuse squared. So your two legs, it does not matter what order, and it also does not matter where x is. Okay? So if I take my two legs, that would be x squared and 10 squared equals the hypotenuse squared. And I'm going to solve for x. So first, I'm going to simplify everything down. I get x squared plus 100 equals 625. So 25 squared is 625. Then I'm going to subtract over 100 to get my x squared alone. And then I'm going to square root both sides. Now, 625 is a large number. I would check always to see if it's perfect. So if you do type in your calculator, it's not. So that kind of stinks. So that means I'm going to have to do simplest radical form. So I have to think of numbers that go into 625, or 525, sorry. And I know that 25 times 21 equals 525. And I can break these down further. 25 is 5 times 5. 21 is 3 times 7. So if these are all prime, I see a pair. So my answer is 5 radical 21. That's the length of x in simplest radical form. To get a little more challenging, we're going to put radicals in the mix. So remember the Pythagorean theorem, you take your two legs, whatever they are. So radical 2 I got to square, plus 4 radical 3 equals x squared, the hypotenuse. So just a review, if I'm squaring square root, squaring and square rooting, they undo each other. So what I'm left with is just 2. Okay? And on this problem, there's one like this on your quiz actually. When you're squaring 4 radical 3, you're squaring the 4, so that's 16. And I'm squaring radical 3, which gives me just 3. So I'm showing that step. This is right here. I just squared this part over here. Equals x squared. So I'm going to take 2 plus 48, 16 times 3 is 48, equals x squared. I get 50 equals x squared, and then I need to square root both sides. So I need to do simplest radical form as usual. So 50 is 5 times 5 times 2. If I break it all the way down, I see a pair of 5s. So 5 radical 2 is my answer for x. Next one, you're going to learn how this one's pretty interesting. Pythagorean theorem. Take your legs, square them, add them together, and that will equal your hypotenuse squared. So some people start doing some goofy things here when simplifying. If I have x squared plus x squared, remember there's invisible ones in front of these. So if I have a 1x squared and another 1x squared, I now have 2 of them, 2x squareds. 14 squared is 196. Next, I need to get that x squared alone. 2 is being multiplied to it, so I'm going to divide both sides by 2. I'm left with x squared equals 98. Just like before, I'm going to square root both sides to get x alone. 98 is not a perfect square, unfortunately, so I'm going to break it down into its prime factors, which is 7 times 7 times 2. So I see a pair of 7s. Take that out. 7 radical 2 is the answer for x. Letter D, we're going to have to figure out what x is. Now, who remembers? Remember these little tick things? There's a special quadrilateral. What special quadrilateral is that? That's a rhombus. Okay. So remember, a rhombus, the diagonals are perpendicular. Oh, look at all those right triangles. There they are. So this is the trick with this one. What you want to do is try to isolate one of your right triangles here. I picked this one just because it has the most lengths being pointed to it, and it helps to redraw it off to the side. So if I were to relabel this, this would be 2x, this would be x, and since the rhombus, all the sides are the same, this 3, it also goes over here, so I'm going to write 3 over there. So now I'm going to have to do Pythagorean theorem. So I'm going to take 2x squared plus x squared equals my hypotenuse squared. Now notice I put parentheses around the 2x. You're squaring the entire side. This is a very common mistake on that quiz. People write it's 2x squared. It's not. It's 4x squared. Because you need to also square the 2, not just the x. So that is 4x squared. Another way you can kind of show this, 2x times 2x, that's what 2x squared is. 2 times 2 is 4. X times x, x squared. Okay. Again, same like the last one, there's an invisible 1 in front of that x squared, so when I simplify it, I get 5x squared equals 9. Then I need to divide both sides by 5 to get my x squared alone. And then I have a fraction. Don't freak out, it's fine. Okay. You've dealt with simplifying fractions before when you've been rationalizing. So I'm going to square root both sides. Okay. So when I do this, this is the same thing as square rooting the top, the numerator, and the denominator. So with fractions, when we went over this, you need to first look for perfect squares. And there are. On the numerator, I have a perfect square. Square root of 9 is 3, and then I have that radical 5 in the denominator. Now, that denominator looks disgusting, so you have to rationalize it. So that's the part where we did that fancy looking one. So I multiply by radical 5 over radical 5, which technically is 1. But what that's going to do is make this answer look a lot nicer. So on the numerator, the 3 is not under radical 5 is, so all you do is write them next to each other. And radical 5 times radical 5 is 5. That was probably the hardest one, you'll see, on a quiz or test. So I want to make sure we went over that. Okay. We're going to do a lot more applications with some of these right triangles. This one I wouldn't worry about right now. We're going to go over some like those later. So I'd like you to go look at B. A lot of when you're first learning Pythagorean theorem, they're talking about ladders against the wall a lot, or shadows and things, just so you can kind of, especially when you're first learning it, they start off a little easier. But we have a 6-foot ladder placed against a wall. Okay, so draw a picture. I usually draw like a weird looking house, and then I draw the ladder. Okay, so obviously I'm a great artist. I'm sure yours probably looks better, but that's okay. We have a 6-foot ladder, so start labeling your picture. So I have a 6-foot ladder placed against the wall with its base 2 feet from the wall. So here's your wall. It's 2 feet away. Okay, how high above the ground is the ladder? So what they're trying to figure out is that one. Okay, now I know this is a right triangle because you're assuming your wall is straight up and down and not meeting. So that's going to be a right angle, and I'm going to use Pythagorean theorem. So I'm going to take my legs, so 2 squared plus x squared, and set it equal to my hypotenuse, which is just my ladder, 6 squared, and solve. So I get 4 plus x squared equals 36. I'm going to subtract 4. Then I'm going to square root both sides. I'm going to come up with pairs. This is 4 times 2. So I see a pair of 4s, 4 radical 2 feet. Now we're going to work on the converse of the Pythagorean theorem. So you have to decide whether it is a right triangle or not. So that's where you plug it in the Pythagorean theorem and see if it works. So you take the 2 shortest legs, or the 2 shortest lengths, and you have to see if they equal the hypotenuse squared. So you simplify it. So 16, 36, 49. Combine, you get 52 equals 49, which is not. So this is not a right triangle because it doesn't, no, I should say. No, it's not a right triangle because it doesn't satisfy the Pythagorean theorem. Same thing with this one. Take the 2 shortest lengths. Those are your legs. see if they equal the hypotenuse squared. So we get 256, 2,304, and 2,500. And we get, when we combine like terms, 2,560 and 2,500. They do not equal, so this is also no. And then the last one is trying to trick me. I don't know if you noticed, but they didn't put it in order. They didn't go least to greatest. So your two legs are first and last. It's the smallest. So I'm going to take the two smallest. So 9 squared plus 36 squared. I'm going to set that equal to the hypotenuse squared. So I simplify, I get 81, 1,296, then 1,521. And I get 1,377 does not equal. Man, none of these worked. All of these were no. They did not satisfy the Pythagorean theorem. For these last two, I think I'm going to talk about the next day or when we go over this as a class. Just because I think it makes more of a difference when you see a visual. Just a little gist of it. It's all like here's where your Pythagorean theorem works. So if you imagine that hypotenuse shorter, so like how it is here. Okay, see how those lengths are different. It makes this triangle acute. If you picture the hypotenuse longer, you can see how this is equal, this is smaller. It's an obtuse triangle. So I'm going to go over these problems after the warm-up the next day.